Hello friend, today we will discuss proof of irrationality of number. We'll take some example here. First is prove that root 2 is a irrational number. Root 2 is an rational number. Here we'll discuss the point. So first let's assume on the contrary that root 2 is a rational number. Then there exists positive integer a and such that root 2 is equal to a upon v, where a and v are coprime. That means their SCM. So here we start. Let root 2 is equal to a divided by b. Square on both the side. So we have root 2 square is equal to a divided by v का whole square. So we can write down 2 is equal to a square divided by b square, or we can say that a square is equal to 2v square. Here we can say that if a square is a multiple of 2, then a is also multiple of 2. Uh, let's take an example here. If 10 square is equal to 100, we can write down 100 as 2 into 15. So here we can say that 10 square is a multiple of 2. So the number 10 is also a multiple of 2. The same thing is here. If a square is a multiple of 2, then a is also a multiple of 2. So we can say that if a is a multiple of 2, then we can write down a is equal to 2m. M is some integer, or we can write down for some integer m. So we can say that a square is equal to 4m square. Put this value in a square is equal to 2b square. So we have 4m square is equal to 2v square, or 2m square is equal to v square. This is our equation number 2, and this is our equation number 1. So from the equation number 1 and equation number 2, from equation number 2 we can also say that if v square is a multiple of, then v is also multiple of 2. So from 1 and 2, a and b, a, b have at least 2 as a common factor. 2 as a common factor. What this contradict the fact that a and b are coprime. This means that root 2 is a rational number. because first now let's take another example. Prove that 3 minus root 5 is an irrational number. Let on the contradictory 3 minus is rational number, then there exists co-prime positive integer a and b such that 3 minus under root of 5 is equal to a divided by b. So we can say that 3 minus a divided by b is equal to root 5, or we can say that 3b minus a upon b is equal to root 5. So here first we prove that root 5 is a rational or irrational number. So let's assume again let's assume root 5 is an irrational number. So let's consider root 5 is equal to p divided by q square on both sides. So we have root 5 square is equal to p divided by q whole square. So we have 5 is equal to p square divided by q square, or we can write down p square is equal to 5 q square. If p is a multiple of 5, then p is also multiple of 5. So we can say that p is equal to 5l, or we can say that p square is equal to 25l square. So put, this is our equation number 1. So put this p square's value in equation number 1. So we have 25l square is equal to 5q square. Here we have 5l square is equal to q square. So again, if q square is a multiple of 5, then q is also multiple of 5. So we can say that this is our equation number 2. So we can say that from equation number 1 and 2, p and q have at least 5 as a common factor. What this contradicts the fact p and q are co-prime. So we can say that root 5 is an irrational number. So root 5 is an irrational number. We have root 5 is equal to 3b minus a upon b. So if root 5 is a irrational number and 3b minus a divided by b is a rational number, so this contradicts the fact that root 5 is an irrational number. Hence 3 minus root 5 an irrational number. Here now another example. Prove that root 3 minus root 2 is an irrational number. Minus root 2 is equal to r, where r be a rational number. Now squaring both sides, so we have root 3 minus root 2 whole square is equal to r square. So here we use identity a minus v का whole square is equal to a square plus v square minus 2ab. So from here we have 3 plus 2 minus 2 root 3 into root 2 is equal to r square. So here we have 3 plus 2, 5 minus 2 root 6. We can write down root 3 into root 2 is equal to root 6 is equal to r square. So we can say that 5 minus r square divided by 2 is equal to 6. Here root 6 is an irrational number. As left hand side 5 minus r square by 2 is a rational number. So we can say that left hand side LHS is not equal to RHS. Hence our assumption that root 3 minus root 2 are rational number.